try to see first of all like how VXLAN L2 VNI works. So what I have done, I have taken two switches. These are two Juno switches, and then I have connected four PCs or four hosts to it. So PC3 is in VLAN 20 and PC4 is in VLAN 20, and I want them to communicate as they belong to the same subnet and they are belonging to different hosts. So I need a tunneling mechanism between these two. So here I am trying to use this VXLAN stretching or VLAN stretching using VXLAN. So what we will do, we will create one bridge domain on both the sides, bridge BD10, let's say BD20, and this bridge domain will have this port which is G002. This port will be attached to that BD, and similarly similar configuration will be done on S2. And now if I say on for the PC1 and PC2, it is under VLAN 10, so it is BD10 I am using. So what we will do, PC1 will send the packet, it will hit the BD10, okay, and then it will see how to reach the PC2's MAC address, because these are in the same bridge domain or same subnet. So PC1 needs to know the MAC of PC2 to be able to reach. So let's see how we configure this. So in the meantime, what I have done, I have only configured this interfaces. So my OSPF is up. I have configured a BGP session between S1 and S2 with the EVPN family, and I have configured some EVPN related stuff on S1 and S2. Let me show you. So now if I see, let's see, run show OSPF neighbor. Okay, so my OSPF is up. Run show BGP summary. So my BGP is up. BGP is not exchanging any amount of prefixes, which is okay for me. Now I will configure a BD. Let me see. Okay, I have configured one BD. BD10 is configured, and BD10 has a port. BD10 has the VLAN ID of 10, and this port is configured under the BD10. So now if I see run show Ethernet switching table, I should see some entry. Okay, it might be that the PC is not sending anything, so that's why we are not seeing. Okay, let's see if we send the ping, assume. So this is PC1, it is under VLAN and its IP is 10.1.0.11. So let me ping something random. Okay, I know that the ping won't be working, so now let's see whether I see something over here. Okay, sorry, I was on the wrong switch. So if I go back to here, let's see whether the BD config is there. Yeah, BD is there. Okay, here I have also the BD 20 is also there, but nothing else is configured. Okay, so under BD10 I can see the one MAC address which I basically pinged over here. Here if I see show IP, I will see this is the MAC address of the host. So now now up to here what we did, that BD10 has one port G1 and BD20 has a port G2. Let me see. So let me see if I have 20 is configured properly or not. Yeah, so 20 is configured. It has a now this is not related now, like I have not made the relation yet. So this port is under VLAN 20, and VLAN 20 is basically BD20 or a switch on in VLAN 20. Now if I configure the VNI stuff or the VXLAN stuff, let's see how to configure it. Set VLANs BD10 question mark VXLAN, okay, and then VNI, I will put the VNI as 5010 for BD10, and 5020 for BD20. Okay, it will give some error, but you can ignore the error. It is the virtual version, so it is just giving the warning. It's not an error basically. Okay, now if I see um, on S2, okay, on S2 what is the configuration I have? Let's see only for BD10. Okay, I don't have the I don't have the VXLAN configured. If I see for 20 what I have configured, I have only configured a VNI with this route target, nothing else. So I think we can configure this other part. So port 2, unit 0, family, Ethernet switching, interface mode. So this is the port towards the PC, the new the PC4 I assume. Okay, family Ethernet switching, members VLAN, members 20. BD20 I have not created, so set VLANs BD20 VLAN ID 20. So now if we see, we have just created a switch and attach a port to it, that's all. BD20, let's filter with 20. Okay, and 10. Okay, so now the things are fine. Now should I be able to ping um, from so let's take this upper version, PC3 to PC4. Now should I be able to ping, let me see, match 20. So I have the VLAN, I have the BD, but I have not created the VXLAN. Here if I see what is the current configuration, yeah, here I have configured the VXLAN also, so I think we can copy the same. Okay, so I have configured. So now should I be able to ping? I think so, we should be able to ping. So if I ping from PC3, ping 20.0.0.22, no, it's not reachable. Okay, now let's see why it is not reachable. So I'm on PC3. PC has the IP of 20.0.0.11. Let me see, show IP. Yeah, and then it is coming to the switch. Now do I see the switching table over here? Yeah, 02 is learned, BD20. Now let me see whether my BGP session is up. Run show BGP summary. Okay, I have the BGP session up. I can see some routes are also there. Let me see. Yeah, this one, maybe this table you can check. Okay, okay, 5 active routes are there. Okay, the first route is my local MAC of PC3, right? And this is my look back at this is my RD, I guess. This is the RD. This is the VXLAN config that I have done. But surprisingly, what I have received from the other end, I have only received this one. Um, this type 3 route. So type 3 route is for the bum replication part, right? So okay, I think I got what is the problem. I actually did not configure this PC4 at all, like show IP5 port. Yeah, I did not configure, sorry. 20.20.20.22 24 gateway. I'm just putting a random IP. I will try to explain. This is not required for now, but we will see later. Okay, now after this configuration, it will probably send some control packets. So probably I will be able to see this route now. mm, so from 2, if I see I have received a route, right? And now will I be able to ping? I think yes. mm, let's see, ping. Yeah, ping is working. Now let's see how the ping is working. So we will take a capture. What is happening we need to understand, right? So let's see. Yeah, filtering with ICMP. Okay, ping. One ping is enough for me. Okay, I can see something. Let's see what it is happening. So there is an Ethernet header. So I assume this Ethernet header will be applicable to this interface IPs, addresses like G000 and G00. So those should be having this max. This MAC, I mean to say. Then my source is 1.1, destination is 2.2, correct only. Then it is a UDP header in between, and then a VXLAN header. So let's see, VXLAN header is 5020. That is correct only. Okay. And then what is the source and what is the destination? My source is 02, my destination is 03. Let's see who is having these things. Okay. So if I see source IP, source MAC, this is 02, and PC4, if I see show IP, this is the destination MAC. So what is happening over here, that the packet is encapsulated from PC1. Okay, PC1 knows, basically PC3 knows the MAC. I think there is an ARP command or not. Yeah, see, there is an ARP command. So we have learned the ARP, means there is a, basically it is creating a switch in between using this EVPN type 2 routes. And if I see, if I have any other routes, no, I will not see more routes. Basically there will be few routes like this type 3 routes. For if I concentrate on 20, right, let me filter with 20, grep, grep 5020. So I have this two type 3 routes, that is, I understand why these are for the bum replication things. Then MAC IP routes, these are my host routes, if you see 2011 and 2022, and this is the MAC routes. There is no IP here. Basically, if you remember, in the route type 2 there are two kinds of router there. One is with only with the MAC, and one is without only with the MAC, and one is MAC and IP. So this is the second one. So these things will be required when we need to do some inter subnet communication, because here what we are doing, we are communicating from PC3 to PC4, right? There is no other thing. Now let's see on PC1, should I be able to ping the other guy? 10.0.0.22. This, if I try to ping, let's see whether it works or not. No, it is not working. Okay, let's see why. Let's do the similar stuff, right? So 5010, let's see. Okay, 5010, I have the local entry, I have this, everything is there, but I think S2 is not properly configured, because I don't see the type 3 route also. Okay, let's see why. BD10, right? Yeah, BD10. Yeah, see here I did not configure this VXLAN part. VXLAN. What was that? 5010. Sorry, VNI 5010 commit. So now if after this commit, do I see? Let's see. Now I can see one more type 3 route came in, right? Now why that PC2's MAC IP is not showing over here? Because this guy has not initiated anything, right? So now if we do start a ping from PC1, it will not know the gateway, so it will try to broadcast, and hopefully this PC2 will be able to reply. No, actually the gateway is not required, because we are pinging the same within the subnet, right? So the gateway won't be used. So let's see the same thing. Ping 10.0.0.22. Yeah, I can see the ping. Now let's see here also. Did I stopped it? Okay, I probably stopped it. Start Vashak. ICMP. Okay, something came. Okay, so now if I see, it is pinging with 5010, right? So now diagram means, with a diagram, if I try to explain what I exactly did, right? So this is switch 1, this is switch 2. I have created one BD 10 over here, one BD 20 over here. Okay, I have attached one host and one host. I think this is 1, and this is, if this is BD10, so this is PC2, and these are PC4, and this is 3. Okay, so this is BD10 or VLAN 10, which is BD20. Let me put it here also, 10, 20. Now what is happening, you can think of uh, a invisible wire, or the bridge has another port which is having a VXLAN encap. So basically here we are having this VXLAN encap, VXLAN encap of 5020. Okay, similar thing is happening over here. VXLAN 5010. So these are the two encaps that is happening. If I put it here on a different color, okay. So now we see that we are able to, from 1 we can ping to 2, from 3 we can ping to 4. But can we ping from 1 to 4? Is it possible? So at this condition, this is not possible. So now we will try to see how we can do it. So for that, what we need to do, we need to uh, create one. Okay, so these bridges are like, this is layer 2 stuff, right? So we if we want to reach to 4 PC4, right, from this is 10 subnet and this is 20 subnet. If we want to reach to 20 subnet, we need a gateway, right? But where is the gateway here? In this switch there is no gateway, right? So we are actually creating an IRB interface which will act as a gateway. So let's assume this has an IP of 10.0.0.1, and this interface has to belong to a VRF, right? This is an layer 3 interface, so layer 3 interface has to belong to any VRF. Let's not create any VRF, so let it be on the VRF 0. Okay, now this is one interface, this is IRB 10. Now for this guy, right, 3, we also need to do something similar, right? 20.0.0.1. Now we will create this part first of all, and then we will see from 10.11 can we ping 20.11. Okay, let's do this. So I will go to S1, set interfaces IRB unit 0 family inet address 10.0.0.1/24. Okay, similarly it will be 20, this will be 20. Let me delete, I should have created with 10. Set. Okay, I have created this IRB interfaces, but are these interfaces, it should be attached to the BD also, right? So I have not done it yet. So set VLANs BD10 L3 interface IRB dot 10 20 sorry 20 20. Okay, now I said that these are belonging to the global VRF, right? So let me prove to you that these are really belonging to the global VRF. Run show route table inet.0. Yeah, see, this is IRB 10 10 1 and this is IRB 20. So these are belonging to the global VRF. Now you can think of, suppose someone sends a packet from someone sends a ping, this PC1 sends a ping to PC3, and we have configured the default gateway as just .1 and here also .1, right? So what will happen, it will see that the destination is on a different subnet, so I have to send the ping to the default gateway, and then the default gateway will means the packet will hit this verb, and then we'll see that the next destination is also is a connected interface to me, so I will send the packet to PC3. So now let's verify this theory whether this works. So I am on PC1. What I am trying to do, ping 20.0.0.11. Okay, now the ping is working, and the TTL is also 63. It means that at least one TTL decrement is happening. So basically the packet is passing through this path. Okay, so now I can do it locally. Now how to do it the other way, means towards the remote guy, right? This is important. That is our main goal. So now what we do, so we need to create similar constructs over here, right? This is an VRF, and then I need an IRB interface over here, IRB interface over here. I will make them as 10 0 0 2 and 22. Okay, so let's configure that. Can I copy this configs, match IRB? Yeah, I think I can. So let's do that. 2020. Yeah, there is no change needed. Control Z, switch to commit. So now we have done this configuration. Now will we be able to ping from 10.11 to 20.22? Let's see this one. So I am on PC1, ping 20.0.0.22. Yeah, it is pinging. Now it is very important that how this ping is working. Okay, so now what is happening, this is basically the asymmetric IRB model. In asymmetric IRB model, what happens that first the packet comes to a first the packet gets generated on PC1. It is hitting the bridge domain, right? Because it is looking for a default gateway. The default gateway resides on the VRF. So now this is the first thing is bridging or switching. So this is the bridging part, that the packet hits on this bridge, right? This is a bridging. Then it sees that, oh, this is my destination subnet is on this IRB interface, right? So I have to switch the packet. So now it switches the packet, like so. This is this routing routes the packet. So this is routing. Then again the packet. So now at this position the IRB is doing a routing, and then again this VLAN 20 or BD 20 will be doing a switching. So the packet will be generated from here, it will go here, it will get routed, then again switched, and then again over here at VD20 it will be just again switched or do a MAC lookup. When I say breached or switched, it is MAC lookup. When I say route, it is like IP lookup. So let's prove this theory, right? So what I said that first the packet will hit this one, right? And then the packet will be encapsulated and sent on this BD20. So when I see the IP ping request, I told you that it will go via this one, right? This is how it will go. Now let's see on the capture how it shows. Okay, yeah, see, this is 10 from 10. I am doing a ping to 2020. Okay, my destination is okay, my interface max, source IP DIP is okay, UDP header is okay. I see the VNI as 520 5020. Okay, and this is very important part to understand. Like destination is showing me 6803, which is nothing but PC4. Okay, let's take one diagram only. This is PC4, and my source is showing as 84F0. Now if I go to S1 and try to understand who is having this 84F0, run show interface 84. Okay, 84F0 is showing something. Probably this works, I don't know. -2. Oh, sorry, I forgot. Okay, this is basically Anshu interface IRB. Let's put it this way easily. Okay, so 84F0 is this IRB's source address. So basically this is my source now, and this is my destination. This is how the packet will go, the request packet. Now this guy will reply. So now how this guy will reply, because the reply has to go to 10. So he will also do the same thing, that it will try to hit the IRB, then it will get so here will be again switched, then routed, then again switched, and then here it will be switched again on the other end. So here the because if you see many documents or many people say that um, switching, routing, bridging, or switching, and then again another switching over here. This is how the IRB model. So the ingress P is doing 3 tasks and the egress P is doing 1 task. So this is basically asymmetric, like why this guy should do 3 tasks and this guy is only doing 1 task. This is not symmetric, like this is not equal distribution. And this is how this one works. And let me show you the reply packet. So the reply packet is coming with VNI 5010. This is expected because this is how the VNI is, the return packet. So yeah, I hope I am able to explain it, but there is one catch. Okay, in asymmetric IRB model, we if we want to communicate to the other subnet, we need to have this suppose this host is not there, assume. Okay, I shut down this interface. If I don't have this interface, so there is no point of having this BD20, right? But if I want to reach to this PC4, I will have to create this BD20, otherwise my traffic won't be working. Because if you remember, this is how it works, right? In the BD, in the traffic passes through the BD, so I will have to create the BD, I will have to create the encaps, right? So for each subnet I need to create those VNIs on all the boxes, and this creates the scaling challenges that if you read documents they will talk about. And to overcome this, we have another model, which is symmetric model, where the the local guy, the ingress, will also do a switch and a route, and the remote guy will do a route and a switch. Okay, so this is the symmetric model. So the symmetric model configuration I'm not doing now, we'll discuss in a later discussion. Thank you.